All right, hi everybody. This is the Math 31 Derivatives Review, question 14. So I've given you the function here, ax over x squared plus b. We're supposed to find a and b such that, well, okay, this is a little different than the previous question because in this case right here, the two bits of information that I'm giving you are with respect to the derivative. Okay, there's no indication of a point because any point that I gave you would have to be on the original function here. This is all about the derivative. So I got to go through and find the derivative here. That's my first step. So f prime of x is going to be equal to, okay, well, I'm going to take the derivative using the quotient rule. So that'll be the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, which in this case will just be 2x, okay, because the b is a constant, all over x squared plus b squared. Okay, now there's not a whole lot that will simplify here, but we'll see what we can do here. This will be ax squared plus ab minus 2ax squared all over x squared plus b squared. And as you can see right there in that numerator, I've got positive a squared minus 2a squared, so this is going to be negative ax squared plus ab all over x squared plus b all squared. Now you might look at that and say, ooh, I could factor out the a and then do some canceling there, but you can't because that first term is negative and this one down here isn't, so they're not exactly the same. I can't do anything with that. But now I know that f primed of 1 is equal to 0. So I know that when I plug a 1 into that, I'm going to get a 0 as a result. So 0 is going to equal negative a plus ab all over, well, that's going to be 1 plus b squared. Okay, well, I think that doesn't give me a whole lot of information, but let's see what else we get here. This next one here says that if I evaluate the derivative at 0, the answer is 1. So 1 will equal, okay, if I plug 0 into this. Now, if you plug 0 into this term goes away. You're left with ab in the numerator. So let's identify that, ab in the numerator, all over. If you plug 0 in, this becomes just b. So the denominator becomes b squared. And that is going to equal a over b. Okay, this is equal to a over b so long as b is not 0. Okay, so we might state here that's true as long as it's also true that b does not equal to 0. Now, if a over b is equal to 1, we can conclude that a is equal to b. Those two must be equivalent. Again, under the stipulation here that b cannot be equal to 0. Now, apply that definition, or this relationship, I should say now, to this previous expression we got here, and we can write here that this is going to equal negative a plus a squared all over 1 plus a all squared. Okay, because a and b are the same, I'm just making all of the b values equal to a. Now, if this expression is going to 0, it can't be because of the denominator. There is no number I can divide by that will take this expression and make it equal to 0. That can only be a result of the numerator going to 0. And now if you factor out a common a out of this, we're going to get negative 1 plus a. There are two options here. A could equal 0, or a could equal 1. Whoops, sorry, going down to the bottom here. Now, so I've got two options here. But remember what we said before. A is equal to b. So if a is equal to 0, b is equal to 0, but b can't equal 0. So what that means is that is not a solution here. And the answer is a equals 1. So therefore, a equals 1 and b equals 1. Those are the values of the variables.